Hey guys, in this session we will cover the topic operators in Python. If you haven't watched the previous video on strings in Python, please check the link in the description. The topics we will cover in this session are the different kinds of operators and the operator precedence. Before we begin, we need to remember that when you perform any operation, you have two components. One, you have the operator, and then next you have the operands. The operator is the symbol that you will use for performing your operation. Like you will have the plus symbol for addition, you have the minus symbol for subtraction, etc. And the operands are the values on which you are performing this operation using the operator. Now let us look at the type of operators. So we have four different types of operators. First we have the arithmetic operator. The arithmetic operator is used for performing basic mathematical calculations like addition, subtraction, multiplication, etc. Next we look at the relational operators. When we have say two operands A and B, I want to find the relationship between them. Like I want to say if A is greater than B or if A is less than B, then I will be using the relation operators. Now identity operators, you'll understand this better when we look at it in more detail, but as of now we can just assume that identity operator is trying to find out if two operands have the same identity or not. And logical operator also, you will understand it if we do it in more detail, but it's basically used to combine existing expressions. So if I have two expressions and I want to combine them and then evaluate them, I will be using the logical operator. Next we will be looking at the arithmetic operators. So arithmetic operators are of two types. First we have the binary operator and next we have the ternary operator. So binary operator will require two values. That is, it requires two operands. Say if I want to do A plus B, I'll need A and I'll need B. If I want to do 2 plus 3, I'll need 2 and I need 3. But for ternary operators, I'll only require one operand. Now let us look at the binary operators. So we have 7 different kinds of binary operators. First we have addition, which is used to add two numbers. Subtraction, which will be used to find the difference between two numbers. Multiplication, to multiply two numbers. Division is to divide two numbers. And division will always give you the answer in float. Now what is floor division? Floor division is used for like if you want to find only the whole number part of the division. For example, when I'm doing 5 divided by 2, my answer will be 2.5 when I am doing with division. Correct? When I'm doing normal division, it's 2.5. But when I'm doing floor division, it is just 2. I have the remainder, which will give me the remainder of when I'm doing a division, like 5 divided by 2, it will give me the remainder as 3. And exponent operator is used to find the exponent. Like if I'm doing 5 power 2, 5 with the exponent operator and then 2, I will get 25. Let us look at ternary operators. So we have ternary plus and we have ternary minus. So the operator ternary plus precedes the operand, which means A equal to 5. When I ask for plus A, it will give me 5. So the way I ask is I should first say plus and then I should say A. So that means the operator is coming before the operand. Same way, if A is minus 5 and I ask for plus A, it will give me minus. Now when we look at ternary minus, when A is 5 and I'm asking for minus A, it gives me minus 5. When A is minus 5 and I'm asking for minus A, it gives me 5. Let us try a few examples of arithmetic operators. So if I do the basic 5 plus 3, I will get 8. If I do 5 plus 4, I'll get 9. 5 minus 3, I'll get 2. Now same way 5 into 3, 15. These are all basic. Now let us look at division. So when I do 5 divided by 1, I will get 5.0. So the division operator always gives me the answer in decimal. Now what if I try 5 divided by 2, I'm getting 2.5. Now floor division, where I do 5 floor division by 2, it gives me 2. It removes the fractional part and it gives me only the whole part. Let us try exponent operator. So this gives me 25. Now we will be looking at ternary operator. So suppose I have a variable A which has 5 and I want to display what is plus A, it will give me 5. This is ternary plus. Now I want to display ternary minus. So I'll do minus A and I'll get minus 5. Okay, suppose B is minus 5 and I want to display ternary plus, I'll get minus 5. If I want to display ternary minus, I will get plus 5. So these are the few examples of arithmetic operations. Let us look at what are relational operators. If relational refers to the relationships that values have with one another. So I have an operand A and another operand B. I should use equal like this, equal to equal to. So if A It'll be A equal to B. That means I'm checking if A is equal to B. So if A is 1 and B is also 1, then the answer will be true. Now if I try not equal to, so the symbol not is given with exclamation, and we'll see if A is not equal to B. If I have the values 1 and 2 for A is 1 and B is 2, then it will give me true for this. If A is 1 and B is also 1, then for not equal to operator, I will get false. Then there is greater than or equal to. So greater than or equal to is like saying, okay, 2 is greater than or equal to 3. 3 is also greater than or equal to 3. So it can satisfy this condition or it can satisfy this condition. Either it should be equal to the same number or it should be equal greater than that particular number. Same goes for less than or equal to. So it should be less than the number or it should be equal to the number. So these are a few important points you have to keep in mind when you're using relational operators. So when you're comparing say 4 and 4.0, so you're going to use the equal to operator and you're going to compare. And you're checking 4 equal to 4.0. So what will the answer be for this? For this it will show true because in Python will remove this 0 that you have in your 4.0. So this will be taken as 4 and then it will compare with this 4 and it will say yeah, they both are the same. Then string comparison. So when I'm comparing a small letter and a capital letter, the small letter will always have a greater value. So if I'm checking if A is greater than capital A, it will give me true. Now you might be wondering how we can check characters. There is something called ASCII code. So each character is assigned to a particular number because the computer only understands binary. So when you are giving a character, it should be converted to ASCII and this ASCII will be converted to your binary. So capital A has an ASCII value of 65 and small a has an ASCII value of 97. The small letter will always be greater than the capital letter. Same way capital B will be 66, small b will be 98. So it will be greater on. Suppose I want to do list comparison wherein I want to find out if two lists are equal, that they'll be considered equal if they have the same elements in the same order. So if I have a list say 1 2 3 and 3 to 1, these two are having the same elements but the elements are not in the same order. So these two lists will not be considered as equal. Let us try looking at how relational operators will work. So first I'm going to compare two characters. I'm taking A and then I'm going to take B and then I'll see if small a is lesser than small b. This is true. Now we all know why, because there is something called ASCII code for each and every character. Obviously the ASCII code of A is less than the ASCII code of B, and which is why we are getting this relation as true. If you want to check that, there is a function called OR which will give me my ASCII code. So here ASCII code of A is 97 and ASCII code of B is 98. So 97 is less than 98 and that's why that came out as true. Initializing a variable, say fruit, and another variable g equal to fruit. Now f equal to g, yeah, this is true. If I try f less than g, this is false. Okay, what if this g was capital F-R-U-I-T? So it's the same word, but G is in capital. So let us see what it is. F is, we'll check if F is equal to G. It's not. Okay. F is less than G. It's false. So that means F is greater than G. Why? Because immediately it looks at the first character and then it sees that, okay, this is lowercase and in G it was uppercase, and lowercase character is always going to have a higher ASCII code. So that's why F will be greater than G. Let me assume G is not fruit, but it's some other word. Let's say fruit market, something like that. Okay, so it's G is not just fruit, it's fruit market. So I've added one more, I've added some more to it. And now if I see F is equal to G, it's not. The length of the string does not matter here. Lowercase f is greater than uppercase f, right? So in fruit, lowercase f, and in fruit market, we have uppercase f. That's what matters here. They're not looking at the string length, nothing like that. Now, if I try in a case where f is equal to, I'm going to change f, okay? Look, f is equal to fruit. Now let me see if f is equal to g. It's not. Is f less than g? Yeah. So in this case, when the case is same, they are looking at the string length. But the moment the case differs, the one that has lower case is given the higher value. So now we have something called identity operators. So in identity operators, we have two operators, which is, and then you have something called is not. So in identity operators, what you do is we'll compare two operands, say A and B, and we're trying to find out if A and B are pointing to the same memory location. So when I write A is B, I'm basically saying A is memory location, B is also pointing to the memory location. Okay, that is my statement. Now, if that was true, like say A and B are actually pointing to the same memory location, I will get the answer as true. Otherwise, I will get the answer as false. With is not, it's exactly the opposite. What I am trying to say will be A is not B. So that means I'm saying A is pointing to a memory location, B is pointing to a different memory location. If that was true, then it will return true. If the statement is false, it will return false. In Python, whenever I have values like say 1, 2, 3, 4, all these values are defined at a particular memory location. Like 1 is defined at 20,200th location, 2 is defined at 20,216th location, 3 is defined at 20,232nd location. When I'm saying A equal to 1, that means my A label is pointing to this. B also equal to 1. When I'm defining a variable, assigning the variable B with 1, that means B is also pointing to this location. So now when I check A is B, this will return what? This will return true. Alright, what if I had said not B equal to 1, but B equal to 2? That means B will be pointing to this memory location, right? Where 2 is. Now when I check A is B, I will get false. So let us try a few more examples in Python. Now we will try using identity operators. So if I have the variable s and I've assigned the number 100 and the variable k, I've assigned the number 100 and I'm saying s is k. See how is highlighted in orange? So yeah, that means it's a keyword. True. Now if I say k is 200 and if I say s is k, will say false. Let me try s is not k. This will give me true. So there's this function id which will give me the memory location at which the variable is pointing to. So if I look at id of s, it is giving me a number. This is the memory location that s is pointing towards. And if I say id of k, it's giving me a memory location. But that is different from what I had gotten earlier. So this is why this is different and this is different, and that is why when I check if s is k, it gives me false over here. If I change k to 100 again, because here I made it to 200, let me make it 100. And now I'm trying id of k. So this gives me like the same number. See, 1488367072. 1488367072. So based on this only my is operator and is not operator works. It just looks at the memory location that your variable is pointing to. Now we will look at logical operators. We have three different logical operators: the OR operator, the AND operator, and the NOT operator. Logical operators are used to combine existing expressions. Like if I have, relational operators, we've tried to find relation between two operators. I'm finding two different relations, relation 1 and relation 2, but I want to combine these and then evaluate. So for that, I'll have to use these logical operators OR and NOT. In Python, every value is associated with some truth value. 1, 2, 3, any character, say A, any string, say fruit, all of these are associated with some truth value. Now first we look at the values types that are classified as false. So first you have the none type, which will be false. So we learned about the Boolean data type. And if Boolean data type is false, the truth value of it is also false. The number 0 is false. If you write it in any form, you write it in decimal form also, it is still false. Empty string, empty list, empty tuple, empty dictionary, all of these are classified as false. Whereas everything else other than this, it is classified as true. So 1 will be classified as true, 2 will be classified as true, 3 will be classified as true, etc. Let us look at the OR operator. So here we have two operands, x and y, and this will be my result. OR operator basically means either one should be true for the answer to be true. For example, here x is true but y is false, but then the criteria is only one of them should be true for the answer to be true. So this is true. Same way, y is true but x is false. Still the answer is true. This is also same. X and y both are true. So this will be true. But in the first case, this is x is false and y is false. So the answer x or y will also be false. Now we will look at AND operator. AND operator, you will need to have both the values as true in order for the answer to be true. So here x is true and y is true, that is why the answer is true. In the third case, x is true but y is false, so it's false. Only if one of them is true, it's not either. Both of them should be true for this answer to be true. Okay, this is false because both are false, so this is false. In this only one of them is true, so this is also false. In this also only one of them is true, so this is also false. Only the last condition where both of them are true is giving me true. Now the NOT operator, I'll only have a single operand. This is pretty simple and quite straightforward. If my y is false, so NOT of y will be true, and if my y is true, then NOT of y will be false. So now let's try a few more examples in Python. So we'll start with OR operator. So 4 equal to 4 or 5 equal to 8. So here 4 equal to 4 is true, 5 equal to 8 is false. But for OR operator, even if one operand is true, the answer will be true. So now you see the answer is true. Let's try another expression, 5 greater than 8 or 5 less than 2. Now here you see 5 greater than 8, it is false. 5 less than 2, this is false. So if both the operands are false in OR, you will get the answer false. Now let us try with AND operator. 4 equal to 4 and 5 equal to 8. Now 4 equal to 4 is true and 5 equal to 8 is false. But even if one operand is false in AND, the answer will be false. 4 equal to 4 and 3 equal to 3. This will give me the answer true. Now let us try the NOT operator. So when I'm writing say NOT of 5, what will the answer be? Now here is where the truth value concept comes in place. So 5 has the truth value of true. So NOT of true will be false. What if I write NOT of 0? We know that 0 has the truth value of false. So NOT of false will be equal to true. Consider this expression 2 plus 5 into 3. Okay, so if I start with addition first, I will get 2 plus 5 7, 7 into 3 21. So that is one answer. The other answer will be if I do 5 into 3 15 and then add this 2, I'll get 17. So I'll get two different answers. I'll either get 21 or I'll either get 17. So which one is the correct answer? We'll have that doubt. So that is why you need something called operator precedence. When you have multiple operators in the same expression, you will need to know which one to start evaluating first. So this is the operator precedence. So first we have the parentheses. So anywhere where you find a bracket, you have to start evaluating what is inside the bracket and then only you will have to solve the rest. Next is exponent. Third is ordinary operator. The fourth is multiplication, division, floor division, remainder. All of them come under the same fourth part. Fifth is addition, subtraction. Sixth is relational operators, identity operators. Seventh is not. Eighth is and ninth will be OR. Here the order is from highest to lowest. So 1 being highest and ninth being the lowest. Now what if you have operators of the same precedence in an expression? Like suppose if I have multiplication and division in a particular expression. So what should I do first? In that case, I should start from the left hand side, and whatever operator I get first, I should evaluate that. This is called as left associativity. Now I'll show you an example. Suppose I have 7 multiplying it with 8, and then I'm doing division with 5, and then I'm doing floor division with 2. So how will I start evaluating? Now you see all of this multiplication symbol, division symbol, floor division symbol, all of them come under this, in this fourth category. So they're all under the same precedence. So I should start evaluating from the left. So I start doing 7 into 8, I will get 56. Then 56 divided by 5, I will get 11.2. 11.2 floor divided by 2 will be 5. So that will be the answer. So that's all for the session. Thanks for watching. Please like, share and subscribe.